From the Startup screen, click on Open, browse to your Chapter 14 folder, and open up Chapter 14 Electrical. In previous exercises, we've looked at the mechanical settings. Now it's the turn for electrical. From the Systems tab, look at the electrical panel. This has a little checkbox which we can click on to access electrical settings. Here we can define all the settings associated with the electrical discipline, whether we want to show hidden lines when objects are stacked on top of each other, and some of your more specific electrical settings that really need to be defined in your project template, like circuit naming by phase. In some geographic locations, A, B and C might be adequate. In other locations, you may have other naming conventions. The electrical data style refers to how some of the data is referred to in the family. Let's just take a look at that. If I click on OK and select a light fitting, let's just drag the Properties palette out and scroll down to the bottom. Here we've got the electrical circuiting, electrical data, and we've got a description, the voltage, the phase, and the load. So we've got different ways of displaying these. Also, how do we want our load names to be displayed? Whether we want to use the source parameters, initial, sentence, or uppercase. The definitions defined under electrical settings should match your local conditions and should be set up in your project template. If you're having to come into this dialog box every time you start a project, then somebody seriously needs to be talking to your Revit manager about having your project template set up before you even start. As you can see from here, there's a fair amount that needs setting up, and they have to be done right in order for the electrical systems to work correctly. Take voltage definitions, for example. Here we have a wide range of voltage definitions, but we also need to use distribution systems to make the circuiting work. Also, as part of the electrical settings are the cable tray and conduit settings. These allow us to define the sizes of annotation display and how we define single line and two line symbology for our cable trays and for the conduits. We can also define the standard sizes that we're going to use for cable tray, and we have similar settings for conduits. If you want to change any of these, select an appropriate symbol from the dialog box. Load calculations. Here we can define load classifications for different types of electrical loads. Here you can see where I select socket. We can choose a type of demand factor. These are fully customizable. We can create our own, duplicate them from an existing. And for the demand factor, we can do the same. Once again, this needs to be carefully set up at the outset. We can also then select the load class for use within spaces. Finally, panel schedules. We will be looking at panel schedules in a lot more detail further on in this chapter. This just gives us an area where we can define specific standard labels, whether we want spares shown in panel totals, and whether we want to merge multi-poled circuits into a single cell, which may be the default for your region or company standard. From your Startup screen, click on Open, browse to Chapter 14, and open the file Chapter 14 Electrical. As with the majority of Revit objects, there are several ways of placing them. The electrical discipline, however, is probably one of those occasions where the majority of elements require a certain degree of hosting. And over the next few exercises, we're going to discover how those elements are hosted. In this first exercise, we're going to look at copy-monitored lighting fittings and the difference between those and light fittings that are hosted on a ceiling. In your project browser, make sure that you have Level 2 Coordination Plan open. From the Collaborate tab, click on Copy Monitor. Select the link file and then click on Batch Copy. The information message here says fixtures have been found. New uncopied fixtures have been found in the linked model, architecture link for electrical. What would I like to do? In this instance, I'm going to click on Copy the Fixtures. Depending on the size and complexity of your project, this may take several minutes to achieve, but you should now see some light fittings on the ceiling plan. I now need to make sure that I click on Finish. If I select one of the light fittings, you can see we have a little monitor symbol, and up on the Contextual tab, we've got an indication that this fitting is being monitored against an external file. So this has created a lighting layout for me based on the architect's design. But what happens if I want to do the lighting design myself? Here I've got an open plan office where I want to place some light fittings. Click on the Systems tab and click on Lighting Fixture. From the Properties palette, select the fitting you want to use. This fitting matches the architect's fitting that was copy monitored. From my Contextual tab, Revit is prompting me where to place this object. Does it want to be on a vertical face? Not really. We're looking to place it on a ceiling. So that's what we're going for. We're placing it on a face. As I go to place the light fitting, you can see that I can hover over the ceiling and click to place it. Click on Modify to finish the command. I can now make sure that this light fitting is lined up with the rest of the ceiling tiles. Use the Thin Line tool so that you can see this accurately. From the Modify tab, click on Align and align the light fitting to match the ceiling tiles. So to complete my design, let's start by arraying this light fitting. Select the light fitting, click on the Array tool, give the array a number, select the array and ungroup. With the light fitting still selected, I can use the Array tool again to array the light fittings vertically. If I think that my spacing needs adjusting, I can move this row by clicking on the Move tool, using the ceiling grid, and adjust the spacing. When I've completed this task, reselect the arrays and ungroup. With those two exercises complete, let's look at the difference between the light fittings. Here's the copy monitored one. We've got the ceiling light. It's a linear 2 foot by 2 foot box, 2 lamps, 277 volts. Exactly the same as the one I placed myself. Let's go back to the copy monitored one. This one tells me that we have no host, and its elevation is 2438. If I select the one I placed, its host is the linked Revit model, but its elevation is the same as the previous one. Although the copy monitored light fitting has no host, it will still report changes in location if the architect changes his design. For this exercise, open the file Chapter 14 Electrical Equipment. In the project browser, scroll down and make sure that you have Level 1 Power Plan open. From the electrical panel, click on Electrical Equipment. And here, we're going to select the metering switchboard to start with. Select the 1219 by 1276 type. Scroll in until you can see the electrical room 118 and place the switchboard near a wall. It's worth pointing out that if you want to choose another wall, and as this element is not hosted, you can press the space bar to rotate it. Repeat the command, and from the Properties palette, choose the 400 amp distribution board TP&N. This is a face-hosted element, and as you can see, it's trying to bury itself in the wall, so pressing the spacebar will enable us to flip it into the right direction. We're going to repeat this for the south, Here we've got an electrical room 112, and in this option, we'll use the 400 amp distribution board SPNN. Again, use the spacebar to flip it to the correct orientation. Finally, on the north part of the building, electrical 125, we'll use the same distribution board SPNN 400 amp and click to place it on a wall. Press Modify to end the command. So far this has been little more than a drafting task, but this is where the power of Revit now comes in, as I want Revit to produce my distribution board schedules for me. I can't do this until I select the distribution boards and pick the type of distribution system they're using. Selecting the distribution board in Plan activates the options bar, and I can select the distribution system. I'll do this for the other boards. The one in 112, the three-phase board in 118, and the metering switchboard. And this is why it's vital that the distribution systems and the voltages are set up in your project template. From the Startup screen, click on Open, browse to your Chapter 14 folder, and open up Chapter 14 Electrical Devices. In this exercise, we're going to deal with placing electrical socket outlets. But if I look at the Systems tab, go to the Electrical panel, and click just below Electrical Fixture, we can see that there are different types of devices that we can place for electrical systems. For this exercise, we're just going to concentrate on electrical fixtures. From the Properties palette, select the twin switch socket outlet, and the type is standard. We can give it an elevation, let's say 500. The offset means that we can offset it from the wall, but for a socket outlet that's on the wall, that's not really appropriate. Scroll into the south part of the building. Here I'm going to start placing some sockets. As you can see, because they're face hosted, they're going to stick to the actual wall themselves. The number of sockets we place for this exercise isn't hugely important, but what I do want to do is have enough that we can create 2 or 3 circuits that will then appear in our distribution board schedules. This is another area where having the right families loaded with the right parameters associated to electrical supply is crucial. Once we've finished placing the sockets, we're almost ready to start adding them to circuits. From your Chapter 14 folder, open up the file Chapter 14, Power Circuits. From the project browser, scroll down and make sure that you've got Level 1 Power Plan open, and then zoom in to the south part of the building. Here we're going to start creating circuits and adding them to distribution boards. In previous exercises, we've seen that we can add them either individually or in groups. So let's do that for power. I'll select one socket, create a power system, I'll edit the circuit, select the other fittings that I want to be on that circuit. I can now select a panel. I can either do this by using the Select panel and choosing the panel, or I can select it from the options bar. We'll look at that at the next circuit we create. Here you can see that I've selected panel LPS1. Once you've finished, click on Finish Editing Circuit. Now let's do the next one. This time, I'm going to select all the socket outlets in a room. I can now click on Create Power Systems, select my panel, and rather than zooming back to find the panel, I can pick it from my list. LPS1. Let's do that again. Select the sockets, create a power system, select a panel. Let's go for LPS1 again, and we'll do it again. Select the sockets, create a power system, select the panel, LPS1. On this last room, I'm going to make a deliberate mistake. I'm going to select some objects with two sockets that have already been placed in another circuit. Because they're already part of a circuit, we don't get the option to create a circuit. So let's clear my selection set and do that again. I'll select a single socket this time, create a power system. Now I'll edit my circuit. I'm going to add to the circuit. Now watch what happens if I select other sockets from other circuits. I have selected elements that are already part of other circuits. They will be removed from the original circuits and added to this one. And it shows me in the plan. If this was the intention, that's fine. If not, I can click on Remove Circuit and select the offending elements. Either select the panel or choose it from the Options bar drop-down and click on Finish. Now that I have my sockets selected and placed into a circuit, I'd like to be able to show my circuit lines. If I hover over one of the sockets and press the Tab key, this shows the circuit. If I select it, I now get the chance to add arc-type wiring or chamfer-type wiring. We also get the options from the Context toolbar on the ribbon. I can repeat this with the other circuits. Press Tab, select, and choose the type of wiring. Hover, press Tab, select, generate wiring. Hover, press Tab, select. This time we'll try the chamfered wire. And finally the last one, hover, Tab select, select, and chamfer again. With the circuits completed for power, we can now turn our attention to lighting. For this exercise, open the file Chapter 14, Lighting Circuits. From the project browser, scroll down and open up Level 2 Lighting Plan. Let's zoom into the south part of the building, and here we're going to start creating circuits for our lighting. To start this off, I'll select a light fitting. When I select a light fitting, you'll notice on the Contextual tab that I can create a power system and a switch system. In this instance, I'm going to create a power system. I now want to edit my circuit and then add to the circuit. So let's add the other lights in that room. I can either select the panel by selecting it from the floor plan, or I can select it from the options bar. Once I've finished creating the circuit, I can click Finish Editing Circuit and proceed to the next one. In this option, I'm just going to select 12 light fittings and create a power circuit. I'm going to select the panel. I'll do that from the options bar. Let's go with LPS2, and we'll repeat that for the next office. Select the fittings, create the circuit, select the panel. We'll go with LPS2 again. And for the last three offices, we'll do those individually. Select the light fittings, create the circuit, select the panel, LPS2. Select the light fittings, create the circuit, select the panel, LPS2. Select the fittings, create the circuit, select the panel, and LPS2 again. Now that I've finished placing the light fittings and creating the circuits, I can tab select the circuit, select it, and put my wires in place. But there's something else I want to do. I want to actually create switching lines as well. And so for that, I'm going to leave the wires off for the time being. From the Startup screen, click on Open, browse to your Chapter 14 folder, and open the file, Chapter 14, Switching Circuits. This exercise is a follow-on from one of the previous ones, about creating lighting circuits. To do this, carry on in Level 2 Lighting Plan. In the previous exercise, we created lighting circuits and connected them to a distribution board. In this exercise, we want to create switching circuits. Select one of the light fittings, and from the Contextual tab, click on Create a Switch System. We now want to edit the switch system, and much like we've done previously, add to the system, either individually or in groups, the different lights that you want to appear on the switch. Once you've selected the light fittings, you can then select the switch, which has now been added to the switch system. Click on Finish. Let's repeat that for the same room. Select a lighting fixture, or in this case, let's select the other 6 for that room. Create a switch system, and then select the switch. There are several ways to show the lights and how they're connected to both the circuit and the switch. Place your cursor over one of the light fittings and press the Tab key. This shows the electrical circuit. If I now select that with the left mouse button, I can choose to generate an archetype wiring from the temporary wiring. Although these are all on the same circuit, they're not switching in exactly the same way. So this method of placing the wires might not be entirely accurate for what we're trying to do. So I'm going to delete some of these and add my own wires. From the Systems tab, click on Wire, making sure you pick up the connection point. Draw the wires in manually. Now what I'll do is link these two, which I know that these 9 fittings are all on the same circuit, but they're not switched together. So this wire, I can override its graphics and change its projection lines to, say, hidden, to indicate a circuit line rather than a switching line. Finally, we want to place a tag to indicate the circuit. Go to Tag by Category, uncheck Leader, and tag the wire. This may need moving, but you can see we get the result we're after. From your Startup screen, click on Open, browse to your Chapter 14 folder, and open the file Chapter 14 Cable Tray. From the project browser, make sure you have Level 2 Power Plan open. Here in the south side of the building, we can see a distribution board. We want to create a run of cable tray that feeds this distribution board. From the Systems tab and the electrical panel, we can see cable tray. From the Properties palette, we can see that we have several different types of cable tray. We have cable tray with fittings, which includes channel, ladder, solid bottom, trough, and wire mesh. We also have cable tray without fittings. Let's first deal with the tray with fittings and without fittings. This is a graphical representation. To display this, select the wire mesh cable tray with fittings. And I'm just going to draw a short run with a bend. Now I'll repeat that without fittings. An almost identical run, but this time we don't see the joins. The families are exactly the same. Let's delete those and look at what else we can do. Select the cable tray command and take a look at the options bar. We've got a width, a height, an offset from our current level, let's say 2400, a bend radius, and the type. Let's go for ladder. If I draw a run, this doesn't look very much like cable ladder to me. In fact, what's happening here is that we are using cable ladder, but Revit doesn't show the actual ladder until you change this to fine level of detail. Notice also that we have the center line displaying. To turn the center line off, we can go to the View Templates, manage my View Template for my power plan, edit the visibility graphic overrides, and for electrical cable tray, we turn off the center line. Let's just move this out of the way slightly and see what happens if I want to create a run that starts lower down. Go back to my Systems tab, create cable tray, I'll specify an offset where we're starting from. I'll draw my run, and at this point I'm going to drop to 1200. Click on Apply and Modify. You can now see that we've got a drop showing. And if I go to my elevation and scroll into level 2, you can see several things. Firstly, the view is in coarse level of detail. Let's change it to fine. Secondly, my cable tray is below the ceiling. So at this point, we can move it. Let's say this is 2750. And we may even want to move the run over so that it runs down alongside the distribution board. If I go back to my level 2 power plan, you can see that my layout is adjusted to suit. Connecting to the cable tray is simple. Click on cable tray. I'll inherit the elevation, specify a size, and just select a point to draw from. Revit creates a T-fitting. If I want to, I can select the T, and by clicking on the plus sign, turn it into a cross. Changing the size of these is just as easy. Let's remove my previous example. I want to draw a cable tray from the cross. I can select the cable tray and change its width. In this instance, we've been provided with a reducer that's a standard fitting. Alternatively, we can select the size on the cross piece and change this to 200. As you can see, we might not get the result we were after. So probably the best way to do this is delete those sections and see what happens when I join these back up again. Joining two cable trays together, if they're forming a continuous run, we'll create them as one cable tray. From your Chapter 14 folder, open the file Chapter 14 Conduit, and from your project browser, make sure you have Level 2 Power Plan open. Here, we want to create some conduit runs from the distribution board. So I'm not going to do this straight away from the plan. Instead, let's double-click on the elevation head. This takes us to elevation 1A. And at this point, I'm going to select the distribution board. These round nodes are connection points for connecting conduit. If I right click, I can draw conduit from face. Now here's the clever thing. Revit now gives me a connecting point and shows me where that connecting point will be on that top face. So I can specify an offset from the left and an offset from the back. Now when I click Finish Connection, I can start drawing my conduit from that location. Just as the rest of Revit's system families, conduits come with different types. And I can draw my conduit run. To modify the conduit, I can select it and either drag it or click on the Move tool. Here we've got the diameter specified on the options bar. And as with other families within Revit, I can press on Tab to select the entire run and change the size of the conduit. As you can see from this view, the run we have here is conduit without fittings. We can change this to conduit with fittings. If I do this to both ends and tab select the run, I can also use this new tool in Revit MEP 2013 to reapply the type and give me the correct fittings for that entire run. If I had multiple conduit runs here, I could carry on doing this process of selecting conduit, selecting the face I was starting from, and drawing the conduit. But Revit does have a tool for me for creating parallel conduits. Let's see what that does. We do have an option whether we want the same radius bend or concentric radius bends. Let's go with concentric. Here I'm going to specify a horizontal number of 4 and a horizontal offset of 100. A vertical number of 1, so we don't need to add an offset. As I hover over one of the conduits, you can see Revit is showing me where the parallel conduits will go. And if I press the Tab key and select, we'll get an entire run. The warning tells me that these fittings don't support the concentric bend radius, so the bend radius of the conduit fittings will be the same. We can view our results from the default 3D view. Now this looks a mess. We can't actually see anything. So let's right-click on the view cube and orient to an elevation, which was elevation 1A. Scroll in and rotate the view slightly, and we can see how our design is progressing. Change level of detail, and this is now beginning to give us a presentation style drawing.